Hello dear students, in this video we will see the previous year questions and questions from sample papers from chapter 7, which is financial mathematics. Now this chapter financial mathematics, it has a weightage of 15 marks. So first we will see the questions from last year's board paper and last year's compartment question paper, and then we will see the questions from last year's sample paper and this year's sample paper. So here we have the first question. Find the present value of a perpetuity of rupees 18,000, which is payable at the end of 6 months if money is worth 8% per annum, compounded semi-annually. So this is a very easy question. We have to find the present value of perpetuity of rupees 18,000 that is payable at the end of 6 months when money is worth 8% per annum and it is compounded semi-annually. So first let us write what is given and then the formula, and then let us find the answer. So here R is given as, that is the periodic payment, it is given as rupees 18,000, and then we have I it is 8% per annum compounded semi-annually. So it is 8% divided by 2. It is 0.08 by 2, which is 0.04. Now the present value of perpetuity, it is given by, here the payments are made at the end of 6 months. So here the present value of perpetuity is given by R by I. So it is 18,000 divided by 0.04, or it is equal to 4,50,000 rupees. So this is the present value of perpetuity. So here writing what is given and finding the value of I carries 1 mark, writing the formula and getting the answer carries 1 mark. Next question, find the effective rate which is equivalent to nominal rate of 10% per annum compounded monthly. Given 1.00833 whole raised to 12 is 1.1047. So here we have to find the effective rate which is equivalent to a nominal rate of 10% per annum that is compounded monthly. So this is again a easy question. So here the nominal rate R, it is given as 10%, which is 0.1, and it is compounded monthly. So the number of conversion periods, it is 12. We have 12 months in a year, so M is equal to 12. The formula effective rate is given by R effective is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.1 upon 12 the whole raised to 12 minus 1. It is 1 plus 0.1 by 12, it is 0.00833 the whole raised to 12 minus 1. It is 1.00833 whole raised to 12 minus 1. This, the value is given here, it is 1.1047 minus 1, which is 0.1047. This is 10.47%. So the effective rate is 10.47% per annum. So this is the effective rate. So here writing the formula carries 1 mark, substituting the values and getting the final answer carries 1 mark. A total of 2 marks for this question. Moving on, Abe bought a mobile phone for rupees 30,000. The mobile phone is estimated to have a scrap value of rupees 3,000 after a span of 3 years. Using linear depreciation method, find the book value of the mobile phone at the end of 2 years. So here they have given the cost of the mobile phone, the scrap value, and the useful life. We have to find the book value of this mobile phone at the end of 2 years. So for that, first let us find the annual depreciation. So here the cost, see, it is rupees 30,000. Scrap value is rupees 3,000. And useful life N is 3 years. So we have annual depreciation D as C minus S upon N. It is 30,000 minus 3,000 upon 3, which is 27,000 by 3. It is rupees 9,000. Here we need to find the book value of this at the end of 2 years. So book value at the end of 2 years. It is nothing but it is the original cost minus the number of years into depreciation. So it is 30,000 minus 2 into 9,000. So it is 30,000 minus 18,000, which is rupees 12,000. So this is the book value of the mobile phone at the end of 2 years. So this is a question for 2 marks. Now moving on, a man wants to deposit a lump sum amount so that an annual scholarship of rupees 3,000 is paid. Rate of interest is 5% per annum. Calculate the lump sum amount required if the scholarship is to start in the beginning of each year and continue for ever. So here it is finding the present value of perpetuity, but then here the scholarship is going to start at the beginning of each year and continue for ever. So the formula will be R plus R by I. The equal amount which is required at the beginning of each year is rupees 3,000 and rate of interest is 5%. R is rupees 3,000 and I is 5%. It is 0.05. So the present value of perpetuity it is given by R plus R by I. So it is 3,000 plus 3,000 by 0.05. This is 3,000 plus 3,000 into 100 upon 5. This will go 20 times. As a result, we have 3,000 plus 60,000. This is rupees 63,000. So here again, writing the formula carries 1 mark, substituting the values and finding the answer carries 1 mark. A total of 2 marks for this question. So here the lump sum amount required is rupees 63,000. Therefore, lump sum amount required equal to rupees 63,000. Next question. A man borrows rupees 3 lakhs at 6% per annum compound interest and promises to pay off the debt in 20 annual installments beginning at the end of first year. Find the amount of annual installment. So here we can see that a man borrows rupees 3 lakhs at 6% per annum and that too at compound interest, and he promises to pay in 20 annual installments, that is beginning at the end of the first year. We have to find the amount of annual installment. So here instead of equated monthly installment, we have annual installment. So again it is the same formula which we use, the same EMI formula, except that here it is not compounded monthly, it is compounded yearly. So here the loan amount is rupees 3 lakhs. The rate of interest it is 6% per annum. So it is 0.06, and here n is the number of installments which is 20. So the annual installment R it is given by P into I upon 1 minus 1 plus I the whole raised to minus n. So here the formula is the same, except that here it is not compounded monthly. The interest is not compounded monthly. So we will have the interest per annum directly, and again the number of installments it is also 20 only. It is not 20 into 12, it is only 20 annual installments. So here n is 20. So from this we can find the annual installment R. So this is 3 lakhs into 0.06 upon 1 minus 1 plus 0.06 the whole raised to minus 20. So here this 3 lakh into 0.06 it is 18,000 upon 1 minus This 1.06 whole raised to minus 20, it is 0.312. So this is 18,000 upon 0.688. Now this, when we simplify, we get it as approximately equal to 26,162.8. So this is the annual installment. Therefore, annual installment is equal to rupees 26,162.8. So this is the annual installment. And this question carries 2 marks. Moving on, the next question, the revenues of a company over a period are given as follows. So we have for various years from 2015 to 2018, the revenue in thousands of rupees is given. We have to calculate compound annual growth rate over the 3-year period spanning the end of 2015 to the end of 2018. So here they have directly given that we have to find the compound annual growth rate over this 3-year period. Here, although there are 4 years, we should not get confused. We calculate this compound annual growth rate as, it is given by compound annual growth rate is equal to ending value upon starting value, the whole raised to 1 by n minus 1 into 100, where SV is the starting value of investment and EV is the ending value of investment. So here the starting value of investment, it is at the end of 2015 or it is at the beginning of 2016. So at the beginning of 2016, it is 100,000 rupees. And at the end of 2018, it is 200,000 rupees. So here as a result, it is only a period of 3 years, 1, 2 and 3. So here n is 3. So let us write what is given. Ending value is rupees 200,000. Starting value is rupees 100,000. And n is equal to 3 years. So using all these, we can find the compound annual growth rate. Compound annual growth rate is 2 lakhs upon 1 lakh, the whole raised to 1 by 3 minus 1 into 100. So here we have 2 raised to 1 by 3. 2 raised to 1 by 3 is 1.26. So this is 1.26 minus 1 into 100, or it is equal to 0.26 into 100, which is 26%. Therefore, compound annual growth rate is equal to 26%. So here again writing the formula carries 1 mark, substituting the values and getting the final answer carries 1 mark. Madhu exchanged her old car valued at rupees 1,50,000 with a new one priced at rupees 6,50,000. She paid rupees X as down payment and the balance in 20 monthly equal installments of rupees 21,000 each. The rate of interest offered to her is 9% per annum. Find the value of X. Given that 1.0075 whole raised to minus 20, it is 0.86118985. So here we can see that Madhu exchanged her old car, which is valued at rupees 1,50,000 with a new one whose price is rupees 6,50,000 and the down payment which is paid is rupees X and the balance is paid in 20 EMI of rupees 21,000 each. The rate of interest which is offered is 9% per annum. Here we have to find the value of X. So here the down payment, it is given as X and then the purchase price, it is 6,50,000 minus 1,50,000 because she has exchanged her old car which is valued at 1,50,000 with this new one. So this is 6,50,000 minus 1,50,000, which is rupees 5 lakhs. So this is equal to rupees 5 lakhs. but she has already made a down payment of rupees X. So the amount for which she has obtained loan, which is the balance or the amortized amount P, it is given by 5 lakh minus X. So this is the amortized amount. And next we have the rate of interest I. It is given by 9%. So it is 9% divided by 12, or it is 0.09 by 12. It is 0.0075. And then N is, here it is given, she has made 20 monthly equal installments. So N is 20. Next we have EMI R. Here it is given, she paid the balance in 20 monthly equal installments of rupees 21,000 each. So here the EMI R, it is rupees 21,000. So from this we have to find X. Now we know that the EMI formula, it is given by R is equal to P into I upon 1 minus 1 plus I the whole raised to minus N. So from this we have P is equal to R into 1 minus 1 plus I the whole raised to minus N upon I, or it is 21,000 into 1 minus 1 plus I is 0.0075 the whole raised to minus N is 20 upon 0.0075. So this is 21,000 by 0.0075, it is 28 lakhs into 1 minus 1.0075 whole raised to minus 20, it is 0.86118985. So this is 28 lakhs into 0.13881015. So this, when we multiply, we get it as 388,668.42. It is 3,88,668.42. So this is the amortized amount. We have P as 5 lakh minus X. So from this we can find X. This implies 5 lakh minus X equal to 3,88,668.42. From this we have X is equal to 5 lakh minus 3,88,668.42. So this is 1,11,331.58. So this is X. Therefore X is equal to rupees 1,11,331.58. So this much is the down payment which is made. So here writing what is given carries 1 mark. Then writing the formula for EMI, substituting the values and getting the answer carries 2 marks. A total of 3 marks for this question. Moving on, what nominal rate compounded monthly will be equivalent to 6% compounded semi-annually? Given log of 1.0609 and anti-log of this value. These values are given. So this is a slightly tricky question. So here we have to find the nominal rate that is compounded monthly, which will be equivalent to 6% compounded semi-annually. So first we have to find the effective rate when 6% is compounded semi-annually, and that effective rate we have to equate it to some X rate which is compounded monthly, and from that we have to find X. So while doing the problem, it will be easy to understand. When 6% is compounded semi-annually, we have R as 6%, or it is 0.06, and here the number of conversion periods M. Here it is compounded semi-annually, so M is 2. Effective rate R effective, it is given by 1 plus, let us take this as R1 and M1. 1 plus R1 by M1 the whole raised to M1 minus 1. So it is 1 plus 0.06 by 2 the whole square minus 1. it is 1 plus 0.03 the whole square minus 1. So 1.03 the whole square minus 1. Here 1.03 the whole square is 1.0609 minus 1. So this is 0.0609. So this is R effective. And now let us let R effective equal to 0.0609 when x is compounded monthly. So here we have to find this x. This nominal rate compounded monthly, that is equivalent to 6% compounded semi-annually. So when 6% is compounded semi-annually, we got the effective rate as 0.0609. So for this rate, let us take x% be compounded monthly. So in this case, we have R2 as x and M2 as 12, which is compounded monthly. So this implies R effective is equal to 1 plus R2 by M2 the whole raised to M2 minus 1, or 0.0609 equal to 1 plus x by 12 the whole raised to 12 minus 1. Or if we have here minus 1, if we bring it to the other side, we will get 1.0609 equal to 1 plus x by 12 the whole raised to 12. Let us take log on both sides. So if we take log, we get log 1.0609 equal to 12 log 1 plus x by 12. So from this we have, so here from this we will have log 1.0609 is 0.0257, 0.02567 divided by 12. Bringing this 12 to this side, it will be log of 1 plus x by 12. Or we have log of 1 plus x by 12. It is equal to, now this when we divide 0.02567 divided by 12, we will get 0.002139. So log of 1 plus x by 12 will be 0.002139. As a result, 1 plus x by 12 will be anti-log of this. So here we got 1 plus x by 12 as anti-log of 0.002139. So this value is given in the question. It is 1.00493. So this is 1 plus x by 12. So from this we will have x by 12 as 1.00493 minus 1, or it is 0.00493. This is x by 12. Or we will have x as 0.00493 into 12. So this is 0.00493 into 12. When we multiply, we get it as 0.05916. Therefore, we got x as 0.05916, or it is equal to 5.916%. Therefore, 5.916% is the required nominal rate. Moving on, calculate the EMI under flat rate system for a loan of rupees 5 lakhs with 10% annual interest rate for 5 years. So here this is also a very easy question. We have to find the EMI using flat rate system. Here the loan amount is rupees 5 lakhs and the annual interest rate is 10% and the number of years is 5. So here the loan amount, it is given, it is rupees 5 lakhs. The rate of interest I, it is 10% or it is 0.1. So interest for 5 years, it will be 5 lakhs into 0.1 into 5. So for 1 year it will be 5 lakh into this 10%. Here it is flat rate system. So the total interest for 5 years will be 5 lakh into the interest rate into the number of years, which is 5. So it is 5 lakh into 0.1 into 5, which is 2,50,000. And next we have the number of time periods. It is equated monthly installment. So for 5 years we have 5 into 12, which is 60 months. So N is 60. EMI R using flat rate system, it is given by P plus I upon N. So here P is 5 lakhs plus I is 2,50,000 upon N is 60. So this is 7,50,000 upon 60. So this, when we simplify, it is 12,500. Therefore, EMI is equal to rupees 12,500. So this is the EMI using flat rate system. Next question, a machine costing rupees 2 lakhs has effective life of 7 years and its scrap value is rupees 30,000. What amount should the company put into a sinking fund earning 5% per annum so that it can replace the machine after its useful life? Assume that a new machine will cost rupees 3 lakhs after 7 years. So here the cost of the machine is 2 lakhs and it has an effective life of 7 years. And this 2 lakh machine has a scrap value of 30,000. But for buying a new machine, it is given the cost of new machine, it will cost rupees 3 lakhs after 7 years. So we have to consider this cost into consideration and this scrap value, because this is the amount that we will get after 7 years from the existing machine. So using this information, we have to find the amount the company should put into the sinking fund that is earning 5% per annum so that it can replace the machine after its useful life. So here the amount it is put, it is at the end of every year. So here N is 7. The amount of sinking fund A at any time, it is given by A equal to R into 1 plus I the whole raised to N minus 1 upon I, where R is the periodic payment, I is the interest per period and N is the number of payments. Here we have the amount in the sinking fund A as cost of machine minus salvage value. Here the cost of the machine at the end of 7 years, the new machine will cost rupees 3 lakhs. And salvage value is the value of this existing machine. So it has a scrap value of 30,000. So A is 3 lakh minus 30,000, which is rupees 2,70,000. So this is A. So using this as the lump sum amount to be accumulated, we have to find the periodic payment R. So here we have A, it is 2,70,000, then I, it is given as 5% per annum. It is 0.05 and N is 7. So using all these, we can find R. 2,70,000 equal to R into 1 plus 0.05 the whole raised to minus the whole raised to 7 minus 1 upon 0.05. So this is R into 1.05 the whole raised to 7 is 1.407 minus 1 upon 0.05. So this is R into 0.407 upon 0.05. This is 2,70,000. So from this we have R is equal to 2,70,000 into 0.05 upon 0.407. So 2,70,000 into 0.05, it is 13,500 upon 0.407. So this, when we simplify, we get it as 33,169.53 rupees. Therefore, amount to be set aside, it is equal to rupees 33,169.53. So this is the amount that has to be set aside at the end of each year. Next question. A startup company invested rupees 3 lakhs in shares for 5 years. The value of this investment was rupees 3,50,000 at the end of second year, rupees 3,80,000 at the end of third year, and on maturity the final value stood at rupees 4,50,000. Calculate the compound annual growth rate on the investment. So here we can see that there is a startup company which invested rupees 3 lakhs in shares for 5 years. And then how this invested value grew over a period of time, it is given here. But the final value, it stood at rupees 4,50,000. We have to find the compound annual growth rate on this investment. Very easy question. So here the compound annual growth rate, it is given by ending value upon starting value, the whole raised to 1 by n minus 1 into 100. So this is the formula for compound annual growth rate, where SV is the starting value of investment and EV is the ending value of investment. So here starting value, it is rupees 3 lakhs. Ending value is rupees 4,50,000 and n is equal to 5 years. So using all these, we can find the compound annual growth rate. So it is ending value 4,50,000 upon starting value 3 lakhs, the whole raised to 1 by n, that is 1 by 5 minus 1 into 100. So this is 1.5, the whole raised to 1 by 5 minus 1 into 100. 1.5, the whole raised to 1 by 5 is given in the question. It is 1.084 minus 1 into 100. So this is 0.084 into 100, which is 8.4%. Therefore, compound annual growth rate, it is equal to 8.4%. So this is the compound annual growth rate. Moving on, a music band company has gained much popularity all over the country. They buy a bus to travel to their destinations. The purchase price of the bus is rupees 88,50,000. The bus will be depreciated linearly over 10 years and will have a scrap value of rupees 25,50,000. The first subdivision, determine the rate of depreciation, then determine the book value of the bus at the end of 5 years, and then when will the bus be worth rupees 44,40,000. So here this is a question on depreciation which carries 4 marks. So here they have asked, determine the rate of depreciation. So for that, first let us find the annual depreciation and then the depreciation rate. So the cost, it is given by rupees 88,50,000. Scrap value is rupees, it is given here, 25,50,000. And then the useful life of the asset, it is 10 years. So n is 10 years. Annual depreciation D is given by C minus S upon n. So it is 88,50,000 minus 25,50,000 upon 10. So this is 63 lakhs upon 10. or it is rupees 6,30,000. So this is the annual depreciation D. Now the depreciation rate, it is given by the annual depreciation D upon the cost of the asset into 100. So this is 6,30,000 upon the original cost of the asset is 88,50,000 into 100. Now this, when we simplify, we get it as 7.12%. So this is, now this value will be 0.0712 into 100 will be approximately 7.12%. So this is the rate of depreciation. Next we have determined the book value of the bus at the end of 5 years. So here book value at the end of 5 years, it is the original cost minus n into annual depreciation charge. Original cost is 88,50,000 minus 5 into annual depreciation is 6,30,000. So this is 88,50,000 minus 31,50,000. So this is 57 lakhs. So this is the book value of the asset at the end of 5 years. It is rupees 57 lakhs. And next question, when will the bus be worth rupees 44,40,000? So let us take, let the bus be worth rupees 44,40,000 at the end of X years. So book value at the end of X years, it is given by C minus X into D. So we want to find when it will be 44,40,000. So this implies 44,40,000. It is equal to 88,50,000 minus 6,30,000 into X. So from this we have 6,30,000 X equal to 88,50,000 minus 44,40,000. So this is 44,10,000. 6,30,000 X is equal to 44,10,000. So here all these zeros will go. So from this we have X is equal to 441 divided by 63. Now this is equal to 7. So it is 7 years. So the bus will be worth rupees 44,40,000 at the end of 7 years. So we have all these questions for 4 marks. Moving on, Anil plans to send his daughter for higher studies abroad after 10 years. He expects the cost of the studies to be rupees 2 lakhs. How much must he set aside at the end of each quarter for 10 years to accumulate this amount if money is worth 6% compounded quarterly? So again, this is a sinking fund question. The lump sum amount to be accumulated, it is rupees 2 lakhs. And then the interest is 6% compounded quarterly. And the amount, it is set aside at the end of each quarter for 10 years. So here we have to find how much amount we have to set aside at the end of each quarter for 10 years so that this much amount will be accumulated. So let us take, let amount put in the sinking fund be R. Amount to be accumulated in the sinking fund A, it is rupees 2 lakhs. This is rupees 2 lakhs. And next we have I. I is 6% compounded quarterly. So it is 6% divided by 4. It is 0.06 by 4, which is 0.015. Next we have N. It is set aside at the end of each quarter for 10 years. So it is 10 into each year has 4 quarters into 4. So this is 40. So now we have the sinking fund formula. It is given by A equal to R into 1 plus I the whole raised to n minus 1 upon I. This implies 2 lakhs equal to R into 1 plus 0.015 the whole raised to 40 minus 1 upon 0.015. Or we have 2 lakh is equal to R into, here 1.015 whole raised to 40 is 1.814. 1.814 minus 1 upon 0.015. Or we have R is equal to 2 lakhs into 0.015 upon this 1.814 minus 1 is 0.814 divided by 0.814. So this is 3000 by 0.814. Now this, when we simplify, we get it as 3685.5. Therefore, R is equal to rupees 3685.5. So this much amount should be set aside at the end of each quarter for 10 years so that he will be able to accumulate rupees 2 lakhs when money is worth 6% quarterly. So far we have seen questions from last year's board paper. Now we will see the questions from last year's sample question paper. Find the present value of perpetuity of rupees 600 at the end of each quarter if money is worth 8% compounded quarterly. So this is also a very easy question. We have to find the present value of perpetuity of rupees 600 at the end of each quarter when money is worth 8% compounded quarterly. So here R is rupees 600 and I is, it is 8% compounded quarterly. So it is 8% divided by 4. It is 0.08 by 4, which is 0.02. Present value of perpetuity, it is given by R by I. So it is 600 upon 0.02. It is 30,000. So this is the present value of perpetuity. Present value of perpetuity P is equal to. So here writing what is given and finding the value of I carries 1 mark, then writing the formula, substituting the values, and the final answer carries 1 mark. A total of 2 marks for this question. Next question, what effective rate is equivalent to a nominal rate of 8% per annum compounded quarterly? So this is also an easy question. We have to find the effective rate that is equivalent to nominal rate of 8% per annum compounded quarterly. So here we have R as 8%, it is 0.08, and the number of conversion periods per year, it is compounded quarterly, so M is 4. So the effective rate R effective, it is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.08 by 4 the whole raised to 4 minus 1. So it is 1 plus 0.02 the whole raised to 4 minus 1. It is 1.02 the whole raised to 4 minus 1. Sometimes the value of this 1.02 the whole raised to 4, it will be given in the question. If it is not given in the question, it can be calculated. So this is 1.0824 minus 1, or it is 0.0824. This is 8.24. So the effective rate is 8.24%. So the effective rate is 8.24%. So this is the effective rate. Next question, find the present value of annuity of rupees 1000 payable at the end of each year for 5 years if money is worth 6% compounded annually. So this is also a question for 2 marks. Here we have to find the present value of annuity of rupees 1000 which is payable at the end of each year for 5 years and money is compounded annually at 6%. So here the present value of ordinary annuity P, it is given by R into 1 minus 1 plus I the whole raised to minus n upon I. So here R is rupees 1000, I is 6% or it is 0.06 and n is 5 years. So n is 5. So this is 1000 into 1 minus 1 plus 0.06 the whole raised to minus 5 upon 0.06. So this is 1000 into 1 minus, here 1.06 whole raised to minus 5 is 0.7473. 0.7473 upon 0.06. So this is 1000 into 0.2527 upon 0.06. From this we get P is equal to this. When we simplify, we get it as 4211.67 rupees. So this is the present value of ordinary annuity of rupees 1000, which is payable at the end of each year for 5 years when money is worth 6% compounded annually. This question carries 2 marks. Next question. A person invested rupees 15,000 in a mutual fund and the value of investment at the time of redemption was rupees 25,000. If the compound annual growth rate for this investment is 8.88%, calculate the time period for which the amount was invested. Given log 1.667 and log 1.089, the values are given here. So here the starting value is rupees 15,000, ending value is rupees 25,000. They have given the compound annual growth rate. We have to find the time period for which the amount was invested. So here let us take, let n be the time period for which the amount was invested. Now we have the formula for compound annual growth rate given by ending value upon starting value the whole raised to 1 by n minus 1 into 100. So here let us write what all is given. Starting value is rupees 15,000. Ending value is rupees 25,000 and compound annual growth rate is also given. It is 8.88%. So let us substitute all these in this formula and let us find n. This implies 8.88 equal to ending value is 25,000 upon starting value is 15,000 the whole raised to 1 by n minus 1 into 100. Or from this we have 0.0888. It is equal to this. When we simplify, we will get it as 1.667 the whole raised to 1 by n minus 1. So it is 1.0888. It is equal to 1.667 the whole raised to 1 by n. Let us take this as 1.089. If we take log on both sides, we will get log 1.089 equal to 1 by n log 1.667. So from this we have log 1.089 is 0.037 equal to 1 by n into log 1.667 is 0.2219. 0.2219. So from this we have n is equal to 0.2219 upon 0.037. Now this when we divide, we get it as 5.97 approximately. Therefore, n is approximately equal to 6 years. So here writing the formula carries 1 mark, writing what is given, substituting the values and getting the final answer. All these carries 2 marks. So a total of 3 marks for this question. Next question. A machine costing rupees 50,000 is to be replaced at the end of 10 years when it will have a salvage value of rupees 5,000. In order to provide money at that time for a machine costing the same amount, a sinking fund is set up. If equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded quarterly, then what should each payment be? So here we have a cost of machine given as rupees 50,000. It should be replaced at the end of 10 years and the salvage value is rupees 5,000. So here, in order to purchase a machine at the end of 10 years for the same cost, a sinking fund is set up and equal payments are placed at the end of each quarter. The fund earns 8% compounded quarterly. We have to find the amount of each payment at the end of each quarter that should be made. So let us let the amount put in the sinking fund be R. The amount accumulated in the sinking fund A, it is given by cost of the machine minus salvage value. So it is cost minus scrap value, which is 50,000 minus 5,000. It is rupees 45,000. So this is the amount to be accumulated in the sinking fund. And then we have I as the fund earns 8% compounded quarterly. So I will be 8% divided by 4. It is 0.08 by 4, which is 0.02. And then N is should be replaced at the end of 10 years. Payments are made at the end of each quarter. So N is 10 into 4 equal to 40. So we have A is equal to R into 1 plus I the whole raised to N minus 1 upon I. So this implies 45,000 is equal to R into 1 plus 0.02 the whole raised to 40 minus 1 upon 0.02. Or we have 45,000 into 0.02. This is equal to R into 1.02 whole raised to 40 is 2.208. 2.208 minus 1. So 45,000 into 0.02, it is 900 equal to 1.208 into R, or R is equal to 900 upon 1.208. It is 745.03. Therefore, each payment should be rupees 745.03. So this is the amount that should be set aside at the end of each quarter. Next question. A couple wishes to purchase a house for rupees 15 lakhs with a down payment of rupees 4 lakhs. If they can amortize the balance at an interest rate of 9% per annum compounded monthly for 10 years, find the monthly installment. Also find the total interest paid. So here the value for 1.0075 whole raised to minus 120 is given. So here the purchase price is 15 lakhs and down payment is 4 lakhs. As a result, the amortized amount will be 15 lakh minus 4 lakh, which is 7 lakh. So for this loan amount of 11 lakhs, we have to find the EMI. Interest rate is 9% per annum compounded monthly and number of years is 10 years. So here the amortized amount P, it is given by cost of the house minus cash down payment. So this is P is equal to 15 lakhs minus 4 lakhs. It is rupees 11 lakhs. Then we have I. I is 9% per annum compounded monthly, so it is 9% divided by 12. It is 0.09 by 12, which is 0.0075. And then we have N as 10 years. It is paid for 10 years. So it is 10 into 12, equated monthly installment. So each year has 12 months. So in 10 years, there is 10 into 12, which is 120 months. So using all these, we have to find EMI R. R is equal to P into I upon 1 minus 1 plus I the whole raised to minus N. So here P is 11 lakhs. 11 lakhs into I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus 120. So here R is equal to, here 11 lakh into 0.0075, it is 8,250 upon 1 minus 1.0075 whole raised to minus 120, it is 0.4069. I'm sorry, 4079. So this is 8,250 upon 0.5921. So this, when we divide, we get it as 13,933.5. So this is R. This is the EMI. And we have one more question. Also find the total interest paid. So total interest paid, it is N into R minus P. 120 into R is 13,933.5 minus P is 11 lakhs. So this, when we simplify, we get it as rupees 5,72,020. So this much is the total interest paid. So here writing what is given carries 1 mark. Then writing the formula for EMI carries 1 mark. Substituting the values and finding the value of EMI carries 1 mark. So a total of 3 marks for finding the value of EMI. Then for finding the total interest paid, it carries 1 mark. Now we will see the questions from this year's sample question paper. So for the following questions, 2 statements are given. One labeled assertion A, the other labeled the reason R. We have to select the correct option. So first option is both A and R are true and R is the correct explanation of the assertion. The second option is both A and R are true but R is not the correct explanation of the assertion. The third option is A is true but R is false, and the fourth option is A is false but R is true. So here we have the assertion. If the nominal rate of interest is 12.5% and inflation is 2%, then the effective rate of interest is 10.5%. Reason, if the interest is calculated only at the end of an year, then the effective rate is same as the nominal rate of interest. So here first we will see the assertion and check whether it is true or not. Here the assertion, nominal rate of interest is 12.5%, inflation is 2%. Then the effective rate, it is given by nominal rate minus inflation rate. So it is 12.5% minus 2%, which is 10.5%. So the assertion is true. Now we'll see the reason. The reason, if the interest is calculated only at the end of an year, then the effective rate of interest is same as the nominal rate of interest. So how we usually calculate the effective rate of interest? It is 1 plus R by M the whole raised to M minus 1, where R is compounded for M periods of time. If R is compounded every year, then we will have M as equal to 1. As a result, we will have R effective equal to 1 plus R by 1 the whole raised to 1 minus 1. It is 1 plus R minus 1, which is equal to R. So here if the interest is calculated only at the end of an year, then the effective rate, it is the same as the nominal interest rate. So the reason is also true. But the reason is not a correct explanation of the assertion. So the correct option is option B. Both A and R are true, but R is not the correct explanation of the assertion. Next question, a newspaper printing machine costs rupees 4,80,000 and estimated scrap value of rupees 25,000 at the end of its useful life of 10 years. What is the annual depreciation as per the linear method? So here the cost is given, scrap value is given and useful life is given. The depreciation is calculated as C minus S upon N. So it is 4,80,000 minus 25,000 divided by 10. So it is 4,55,000 divided by 10, or it is 45,500. So the correct option is option B. Next question, an investment of rupees 10,000 becomes rupees 60,000 in 4 years. Then compound annual growth rate, it is given by. So here we have the starting value is 10,000. Then the ending value is 60,000 and N is 4. So the compound annual growth rate, it is given by ending value upon starting value whole raised to 1 by N minus 1 into 100. So ending value is 60,000, starting value is 10,000, whole raised to 1 by N is 4 minus 1 into 100. So this is 6 raised to 1 by 4 minus 1 into 100. 6 raised to 1 by 4 is nothing but 4th root of 6 minus 1 into 100. So the correct option is option C. 4th root of 6 minus 1 into 100. Next question, rupees 2,50,000 cash is equivalent to a perpetuity of rupees 7,500 payable at the end of each quarter. What is the rate of interest convertible quarterly? So here we can see that this is the present value, that is 2,50,000. This is the present value of perpetuity of rupees 7,500. This is R. This is payable at the end of each quarter. So here we have to find the rate of interest that is convertible quarterly. So here let R be the rate of interest. So here we are given P as rupees 2,50,000 and R as rupees 7,500. If we take R as the rate of interest, then I will be R by 4 because it is payable at the end of each quarter, and here rate of interest is compounded quarterly. So I is R by 4. We have the present value of perpetuity P equal to R by I. This implies 2,50,000 equal to 7,500 upon R by 4. Or we have, if we cross multiply, 2,50,000 into R by 4 equal to 7,500. Here 2 zeros will go. So this implies R is equal to 75 by 625. So here this, when we simplify, we get it as 0.12. Therefore, R is equal to 12%. So the rate of interest compounded quarterly, it is 12% per annum. Next question, Mithul invested rupees 3,50,000 in a fund. At the end of the year, the value of the fund is rupees 4,37,500. What is the nominal rate of interest if the market price is same at the end of the year? So here the initial value is rupees 3,50,000 and the final value is rupees 4,37,500. We have to find the nominal rate of interest if the market price is same at the end of the year. So here we are given the initial value of the fund is rupees 3,50,000. The final value of the fund is rupees 4,37,500. The nominal rate is calculated as final value minus initial value upon initial value into 100. So it is 4,37,500 minus 3,50,000 upon 3,50,000 into 100. So this, when we simplify, it is 87,500 upon 3,50,000 into 100. It is 25%. Therefore, nominal rate is 25%. Next question. Sujit purchased a new house costing rupees 40 lakhs and made a certain amount of down payment so that he can pay the balance by taking a home loan from XYZ bank. If his equated monthly installment is rupees 30,000 at 9% interest compounded monthly, reducing balance method, and payable for 25 years, then what is the initial down payment made by him? So here the purchase price is rupees 40 lakhs and he has made some down payment. Let us take it as X, which is what we have to find. They have given the EMI as rupees 30,000 and the interest rate is 9% per annum compounded monthly and it is payable for 25 years. We have to find this down payment, which we are going to take as X. So let us take let down payment equal to X. Then the purchase price, it is rupees 40 lakhs. As a result, the balance will be 40 lakhs minus X. Interest is 9% compounded monthly, so it is 9% by 12, it is 0.09 by 12, which is 0.0075. And here N is, it is repaid in 25 years, so it is 25 into 12, which is 300. So we have EMI R, it is given by R is equal to P into I upon 1 minus 1 plus I the whole raised to minus N. EMI, it is given as rupees 30,000. So this implies 30,000 equal to P into I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus 300. So this implies P equal to, so from here we have 30,000 into, if we cross multiply this 1 minus 1.0075 the whole raised to minus 300 will go to the other side. This is equal to P into 0.0075. So from this we have P is equal to 30,000 into 1 minus 1.0075 whole raised to minus 300 is 0.1062 divided by 0.0075. So this is equal to 30,000 into here 1 minus 0.1062, it is 0.8938 upon 0.0075. Now this, when we simplify, we get it as 35,75,200. Now this P, it is nothing but it is 40 lakhs minus X. This implies 40 lakhs minus X equal to 35,75,200. So from this we have X as 40 lakhs minus 35 lakhs 75,200. Now this when we subtract, we get it as 4,24,800. Therefore, the down payment is rupees 4,24,800. So this much is the down payment. So here writing what is given, then writing the balance, finding I, writing the EMI, all these carries 1 mark, then writing the formula, substituting the values and getting the final answer carries 2 marks. A total of 3 marks for this question. Moving on, 10 years ago, Mr. Mehra set up a sinking fund to save for his daughter's higher studies. At the end of 10 years, he has received an amount of rupees 10,21,760. What amount did he put in the sinking fund at the end of every 6 months for the tenure, which paid him 5% per annum compounded semi-annually? So here we can see that 10 years ago, a person by the name Mr. Mehra, he set up a sinking fund to save for his daughter's higher studies, and the amount that was received, it is rupees 10,21,760. We have to find the amount that he has put in the sinking fund at the end of every 6 months during those 10 years, which paid him 5% per annum compounded semi-annually. So here let us take that the amount put in the sinking fund at the end of every 6 months be R. Then the amount accumulated in the sinking fund, it is rupees 10,21,750. And then the interest rate is 5% per annum compounded semi-annually. So it is 5% divided by 2. It is 0.05 by 2, which is 0.025. And then N is the number of time periods. So here it is 10 years ago and he has put at the end of every 6 months. At the end of every 6 months. So N is 10 into 2, which is 20. So this is the number of time periods. Now we have A equal to R into 1 plus I the whole raised to N minus 1 upon I. So this is the sinking fund formula when the periodic payments are made at the end of each time period. So here A is 10,21,760. This is equal to R into 1 plus I is 0.025. The whole raised to N is 20 minus 1 upon 0.025. So this implies here if we cross multiply 0.025 into 10,21,760, we get 25,544. This is equal to R into 1.025 the whole raised to 20. It is given 1.6386. 1.6386 minus 1. So this implies 25,544 equal to R into 0.6386. So from this we get R as 25,544 upon 0.6386. Now this when we divide we get it as 40,000 because 6386 into 4 it is 25,544. So this is 40,000. Therefore, R is equal to rupees 40,000. So the amount that Mr. Mehra had set aside was rupees 40,000 at the end of every 6 months. So here again writing what is given, then finding I, N, all these carries 1 mark, then writing the formula, substituting the values and getting the final answer carries 2 marks. A total of 3 marks for this question. So these are the various questions from last year's board paper, last year's sample question paper and this year's sample question paper on financial mathematics. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.